All right, we're going to start section 13.3, which deals with the unit circle, which we talked about in the last video, in the last section. And most importantly, the topic of this video and what I want you to learn is radians. Radians is a method for measuring angle measures in terms of pi. If you would press the mode key on your graphing calculator, you would see you have two options for measuring angles: degrees, and the other one is in radians. Radians is always in terms of pi. It is a unit of angle measure based on arc length. And you learned a lot about arc length last year in geometry. Now, I have a picture here. I want you to draw the circle, and I want you to label it as I have done. Theta is the blue interior angle right there, and the green R stands for the radius of the circle. Now, what is a radian? Well, very simply, a radian, 1 radian, is when the arc length is equal to the radius of the circle. When these two distances, the red line distance and that black line distance, when those two distances are the same, theta is equal to 1 radian. Okay? Questions? Make sure you ask. Now, what is 1 radian? 1 radian is approximately equal to 57.291 degrees. Make sure you write that down. Roughly the size of that angle right there, 57.291 degrees. That is the value of 1 radian. All right, so that's the basic idea and the definition of what a radian is. Now let's do a little proof. What is the relationship between radians and degrees? All right, well, to begin with, you learned a formula in geometry that says arc length is equal to the radius times the central angle, which is theta. If you write that as a formula, that's S equals R theta. Now, let's consider what you learned in the prior video about angles of rotation. Right now, my black line of my circle is my initial side. It's fixed. And I'm going to take this blue line, the blue line, which is the terminal side, and I'm going to rotate it all the way around 360 degrees. Now, if I rotate it 360 degrees, that makes my angle theta 360 degrees times the radius is equal to S, which is the arc length. Well, let's talk about the arc length. The arc length, which is the red line going all the way around, what is that called? That's called the circumference. And you learned a long time ago how to find the circumference of a circle. That is 2 times pi times the radius. Well, very simply, there's my formula. If I divide both sides by r, the r's will cancel out, and I have the relationship between radians and degrees. 2 pi is equal to 360 degrees. Memorize that. Burn that in your memory. 2 pi radians. 2 pi radians is 360 degrees. Now, let's use that information to make one of our cheat sheets. Hopefully you printed the big blank circle off Edmodo or off of online, or you got a copy from me. We're going to make a cheat sheet for radians and degrees. Now, this circle looks very similar to the circle we made in the prior video. All the important degrees are going to be on this circle. I'm going to color code this. Degrees is in blue. Now, if you remember, this is 0 degrees or 360, this line right here. And going around the circle, that's 30 degrees. This is 45 degrees. This is 60 degrees, etc. So go ahead and fill in the degrees and leaving room in here between the degrees and the edge of the circle, because that's where we're going to write the radians. All right, so I'm just going to finish this for you. Please feel free to pause the video and copy this if you need to. But these are all the important angles that we are going to use during this unit. There you go. All right. Now, let's put the conversions to radians on the circle. I'm going to do radians in red. Well, we just talked about memorizing that 360 degrees is 2 pi radians. And obviously 0 degrees would be 0 radians. Now, everything works proportionally or following a pattern or symmetrically or however you want to call it. If 360 degrees is 2 pi, half of that is 180, which would be 1 pi. Half of 180 is 90 degrees. Half of pi would be pi divided by 2. Now, if you follow a pattern and you start counting, this is 1 pi over 2. This is 2 pi over 2. So this one has to be 3 pi over 2, which is 270. And then 4 pi over 2 is the same as 2 pi. All right, so now you've done all your multiples of 90. Now let's do multiples of 45. Well, 45 degrees is half of 90. So pi over 2 times a half is pi over 4. That is 45 degrees. And now we're going to count by force, people. This is 1 pi over 4. That is 2 pi over 4. So the next dotted line must be 3 pi over 4. Pi is 4 pi over 4. So the next dotted line must be 5 pi over 4. This one way at the bottom is 6 pi over 4, which will make this one 7 pi over 4. Very good. So now we have all our 45 degree angles in there. Now let's do multiples of 30. How does 30 compare to 360? 30 compares to 360, I believe that is 1/12. So if we're going to change radians or degrees to radians, we need to do 1/12 of 2 pi, which is the same as 360 degrees. And if I do that, I get 2 pi over 12, and that reduces to pi over 6. So therefore, 30 degrees is pi over 6, and that's what we're going to count by now. We're going to count by 6. So 30 degrees is 1 pi over 6. 60 degrees is 2 pi over 6, but that reduces to pi over 3. We're always going to reduce our radians, pi over 3. So 1 pi over 6, 2 pi over 6, that's 3 pi over 6. 120 is 4 pi over 6, which is the same as 2 pi over 3. 150 would be 5 pi over 6. This one is 6 pi over 6. 210 is 7 pi over 6. 240 is 8 pi over 6, which is 4 pi over 3. 270 is 9 pi over 6. 300 is 10 pi over 6, which is 5 pi over 3. And then 330's got to be 11 pi over 6. And there you go, people. There's your cheat sheet. Now, make sure that you have saved the entire outside of this circle out here, because we're going to write a lot of stuff on the outside as well. But the inside of your cheat sheet circle should look like that. All right. Now, that's your conversion chart. So, for instance, if I asked you how many radians 135 degrees is, you'd say 3 pi over 4. But obviously, there are some angles that are not on this chart. So let's write down how to convert. Two formulas, converting degrees to radians and converting radians to degrees. To convert degrees to radians, very simply, whatever I tell you in degrees, you take that times by pi over 180. That's your formula, very simple. So, what is 240 degrees in radians? If I wanted to convert that, I would go 240 times pi over 180, which is basically 240 over 180 times pi. All you got to do is reduce that fraction. And I believe 60 goes into both of that, so that would be 4 pi over 3. And that's how you change degrees to radians for any angle. How about converting radians to degrees? Well, you just go the other way. You take the radians and you times it by 180 over pi. So, what is 6 pi over 5 radians in degrees? Well, 6 pi over 5 times 180 over pi. Now, when you do this, the pi's will always cancel out. So very simply, all I got to do is 180 times 6 divided by 5. And if you do that on your calculator, 180 times 6 divided by 5, you get 216 degrees. And people, that is the summary of what radians are and how they work. If you have further questions, please make sure that you ask me during class.